guys, so welcome to week 7 of distance learning. This is part 3, or this investigation, which is probably the one that most of you guys are going to watch. But this is a point in time where you may get kind of confused, you may get a little frustrated, you may not know the answer, and that's fine. That is perfectly and totally okay, because the whole point is you're just supposed to start to figure it out on your own. So we're going to walk you through it in a few different ways. So now that you figured out what Pangea looked like, the question is, how did those continents come to move? And that's something that Alfred Wegener, who's the guy who came up with the idea, he wasn't even entirely sure of the answer until we found other evidence later on to support his theory. And the question is, are we currently moving towards another giant supercontinent? Have all these continents just come together and broken up multiple times throughout the history of the world? The answer is yes. But you're going to figure out how exactly that happened. So we have a bunch of different phenomena to help you kind of piece together the processes that are happening inside of the Earth. So first of all, this is a candle carousel. Had we been in class, I would have shown you this in person because I have one that's very similar to the one on the right. But all three of these are powered by a small candle. There's no batteries involved. There's no electricity involved. It's just when the candle is on, they start to rotate, and when the candle is out, they stop. So what is the candle heating, and how does that cause the carousel to move? So you need to think very carefully about it. Look at how these guys are designed and then figure it out. Oh, and I actually literally have the one on the right. So it's sad because you would have seen it in person, but that's okay. A GIF works too. So you're just going to answer in this box here. The second phenomenon that we want you guys to look at is hot air balloons. So many of you guys have seen these, at least on TV or in a video or something. I've never been lucky enough to see one in real life. It's on my bucket list. But a hot air balloon is powered by propane, which is gas that is lit on fire. So it's similar to your stove, but it's just like way, way more powerful than your stove, for those of you that have actual flames on your stove. As long as it's continuously filled with warm air, the balloon will leave the ground and float. Once the fire is turned off, the balloon will sink back down to the earth. So they actually have to lay these guys down on their sides for a long time, turn that fire on, and then just use that hot air to actually fill the balloon. And then once that balloon gets filled, the balloon will stand up straight, and then it'll start to go up into the air. So the question is, how does the hot air balloon come back to the ground, and why? Why is it that turning off that flame is going to do something to make that hot air balloon sink back down? What's going on inside of that hot air balloon? Okay, the third phenomenon that we want you guys to take a look at is lava lamps. So observe the movement of wax inside of the lava lamp. Knowing that there's heat coming from the bottom of the lamp that warms the wax, it's actually the light bulb that's inside of the lava lamp. A lot of times that itself will heat up the wax and melt it, or there's a metal coil that heats up and melts the wax. And then once the wax starts to warm, it starts to rise, and then at a certain point, the wax starts to come back down. So the question is, what's happening with the molecules of wax that's causing it to rise and fall inside of your lava lamp? A lot of you guys have glitter in your lava lamps too. Glitter works in a similar way, except it's the liquid itself that's heating up and not the glitter. So that liquid heats up and then causes this same kind of up and down reaction going on. So just explain what you think is going on with those molecules. And then you're going to compare the three phenomena. So they have similarities in common. They also have differences among them too. But what drives all three of these phenomena? Take your best guess at what's happening with the molecules of air or liquid to make them rise or fall. And then if you need some help, you can check out the sea level rise lab that we did, or half of you guys did. And you can read about how molecules react in certain situations. And then you can answer there. So the question is, how does that actually relate to the Earth? So the Earth has layers like an onion, and underneath the surface of the Earth lies magma, which often comes up and out of our volcanoes. And I'm actually going to pause this video here.